Hello everyone, I hope you're doing well. Thank you so much for your great work and for doing your assignments on time, all the assignments on time, and I want you to keep up with the great work till the end of the semester. Today we are starting a new lesson about algebraic vectors. Okay. So far we have learned that any vector in the world must have two things: direction and magnitude. What we have learned was how to represent vectors geometrically. How can we represent a vector geometrically? We did by using two things. Let's say we have vector v. The magnitude of vector v is 5, and the direction is 30, so east, 30 north, something like that. So it is very easy. The angle gives me the direction, and the magnitude, the length, the magnitude gives me the length. So I can represent this vector. I draw a line with 5 centimeters or something that represents this. Maybe it's in Newton, and the angle here, this is the east, and this is the north. Represent the direction, give me the direction, okay? This is how we represent vectors geometrically. Now, we are going to learn how to represent it algebraically. Algebraically means using a Cartesian system, like the x, y in 2D, and x, y, z in 3D. So the vector, if I want to, in Cartesian system, x and y, this is if we have 2D, and the vector will be x, y, z if we have 3D vectors. Okay? Now, let's say we have vector AB. This vector has a tail. We start with the tail, and the last one represents the head of the vector, where it is heading. And this vector has, this is the tail A, and this is the head B. And let us say the coordinates of A is x1, y1, and the coordinates of B is, B, x2, y2. We can get the length, the magnitude of this vector. So this is enough to represent the vector, because the coordinates give us the direction, and we can get the magnitude of this using Pythagorean theorem. We know that the length of this side will be the difference in y, so y2 minus y1, and the difference in here, and the length of that will be the difference in x, x2 minus x1. So we can say that the magnitude of vector AB will equal the square root of x2 minus x1 squared plus y2 minus y1 squared. So if we have the coordinates of the head and the tail, we can get, that give us the direction, because we know that the vector is going this way, and it give us also, we can tell the magnitude by using the distance formula we learned in grade 10, but in some form of vectors. The magnitude will equal this, okay? Now, I want to introduce you to very important concept, which is position vector. We know that parallel vector with the same magnitude and the same direction are the same. So all of these vectors that are parallel and with the same length are all equal, all are the same. So I can represent all of these with a vector that has the same magnitude as those and parallel to them and the same direction. But the only difference is what makes this unique, and we call it a position vector. That its tail is at the origin 0, 0. So position vector is a vector that represents many other vectors. So it is parallel to them, same direction, same magnitude, and its tail is always at the origin 0, 0. Okay? So this is what we mean by position vector, and this concept is very important. Okay, so alright, let us say that I have vector AB, A and B. This is vector AB. And the coordinates of vector A, the coordinates of the tail is 1 and 3. And the coordinates of B, which is the head, is 4 and 5. Alright? I want to get the coordinates of, I want to put this in the position vector. I want to have the position vector that represents this. So what is the meaning of position vector? I'm going to draw a vector that has the same length and the tail is at 0, 0. Okay? So parallel to this, exactly same length, the tail is at 0, 0. So I need to find the coordinates of the head. So let's say this is OP. Position vector represents AB. So AB as a vector equal vector OP, the position vector. What will be the coordinates of P to have this with the same direction and the same length? What did I do to this to go to 0? What did I do to 1 to go to the 0? I shifted 1 to the right. So I have to shift this 1 to the right. What did I do to the 3 to go down to 0? I shifted 3 down, so I have to shift the 5, 3 down. So the coordinates of this vector is 3, 2. The coordinates of the head of this vector, the tail is at 0, 0. And this will make the calculation much easier. So I can say that vector AB is exactly the same as OP, which is AB equals B minus A, which is the coordinates of B minus the coordinates of A, so 5 minus 1, comma, 4 minus 1, sorry, the x's, 4 minus 1, comma, 5 minus 3. And this will give us this. So actually this is the same thing as the coordinates of OP. So in order to find, which is 3 and 2. So in order to find the position vector, or to represent any vector, like let's say this is vector, this is AB, and it has x1, y1, and this has x2, y2, and I want to represent it with this position vector. So vector AB will equal B minus A, and that will give us the head of this position vector, which is x2 minus x1, comma, y2 minus y1. So this is the coordinates of B, and this is vector OB, because the vector AB is B minus A. This will represent give us the coordinates of the head of the position vector that represent vector AB, and the tail will be at the origin. Okay, so this is the first thing I wanted you to know. Now let's say I want to find vector BA. Vector BA, so it is A minus B. Always head minus tail. So vector BA is B minus A minus B. I'm sorry. So now let's say I have I give you A is at -2 and 3, and B is at 4 and -1, and I want to find the coordinates vector AB and vector BA. So vector AB will equal B minus A. So I will just subtract the coordinates of the head minus the coordinates of the coordinates of the head minus the coordinates of the tail. So 4 minus -2 minus comma -1 minus 3. So the coordinates here will be 6 comma -4. For BA, that will be A minus B. So I will subtract -2 comma 3 minus 4 and -1. So 4 minus 2, -2 minus 4 is -6. 3 minus -1 is 4. And when you look at this, you will find that the position vector that represents AB will be 6 and -4. So this is the position vector that represents AB. That is, the coordinates of the head will be 6 and -4. And the other one will be at -6 and 4, which is the same distance but opposite direction, because vector AB is the opposite vector to vector BA. Alright? Okay, so this is how we find the position vector and how we find the vector. Alright, so I will stop here and I will continue in the next video.